Hey everybody, wanted to say hello and welcome you to the first day of February, which is also the first day of Black History Month. And so I'm going to throw a little bit of other stuff into our math video just because I think we might as well use some of this time to get as much talked about as we can. And so I wanted to read to you some information I have about what happened on February 1st, which you're watching this video on February 2nd, so this was yesterday, but this is today's for February 1st as I'm recording this. So February 1st, what happened in history or what's connected with Black History Month that we could talk about? Lots of stuff that happened today. Langston Hughes, one of my favorite poets, Black poet, was born on this day in 1902. If you've never read Langston Hughes, you should give it a try. He's an amazing, amazing poet. And on this date in 1865, the 13th Amendment was signed to the Constitution, which abolished slavery. So also an important day in Black history. And then Black History Month started on this day back in 1926, but really it became a whole month-long celebration in 1976. Pretty interesting. February 1st, who would have known? So anyway, I'm glad that you guys are here watching this video. So we're going to do some work today with the idea of multiplication of fractions, which is what we were doing in class on the 1st of February. So this was yesterday. We were working on multiplication of fractions, but we're also going to be reviewing a little bit of multiplication of decimals and sort of seeing the relationship between those two things, all right? So if you remember, just so we can have some kind of common numbers to work with, some really friendly numbers to work with, because I think that's important for this concept. If you remember way back before winter break, we were talking about what I called benchmark fractions. And I wanted you to have memorized the relationship between fractions, decimals, and percents for certain fractions. And so we talked about 1/4 is a benchmark fraction. And if you could remember, can someone call out to me, what is 1/4 as a decimal? Let's see if you remember that. Good job. That is 0.25. 25 hundredths is the same thing as 1/4. How about 1/2? What is that as a decimal? Yes, 0.5, very good. How about 3/4 as a decimal? Fantastic, 0.75. Very good. You guys are so smart and you remember things really, really beautifully. And we also remember to sort of anchor ourselves to these benchmark fractions and decimals. The idea of, like, if you were to put the dollar in the change machines, you want to play a video game at the arcade, and it's 25 cents, 50 cents, 75 cents. That's 1/4, 2/4, 3/4, right? So that's a good way for you to remember that. A couple more, they aren't technically what I would call the benchmark fractions, but they're ones that I think are really good to memorize that we're going to be using today are the idea of our 1/5, 2/5, 3/5, right? Those are ones that we're going to be working with this afternoon as well. So 1/5 is 0.2 when we do our math. When we remember how we talked about how to turn a fraction into a decimal is 1 divided by 5. And 1 divided by 5 is going to end up with 0.2. So that's one of our 1/5 is 0.2. So 2/5 is going to be two of those, 0.4. 3/5 is going to be just three of these, which is going to take us to 0.6. So those are going to be our numbers we're working with today. I'm going to have you take a moment, pause the video to write these down, these fractions and their decimal counterparts, so that we can work with those in our math work today. So let's get started by pausing the video, copying those down for me. Great, I'm glad you have that all written down. Let me move these things over so I have a nice blank screen to work with. And I'll keep those numbers handy for doing some work. So what I want us to do is just sort of explore a little bit with some of these numbers. The multiplication of a fraction and the multiplication of those same numbers or portions as decimals, right? So the first thing I want to try is, let's do 1/4 times 1/5, right? So those are fractions that we have over here as decimals, but we also have them as fractions, right? And so in class on Monday, we learned about how super friendly multiplication of fractions are. It's just simply multiply across the top and multiply across the bottom. So when we do that, 1 times 1, 1. 4 times 5, that's 20. All right? Very easily done when we're talking just a fraction times a fraction, right? But now I want to take this moment, slide this over a little bit, and I want us to do the same math problem, but multiplying the decimals, just to sort of confirm and to make sure that there's this connection made between 1/4 and 1/5 when we're multiplying them. So 1/4 as a decimal is 0.25. And 1/5 as a decimal is 0.2. So it's a little review of our multiplications. Now you might have noticed that when I wrote this down, I did not line my decimals up. And that's because you don't have to when you're multiplying fractions, or excuse me, when you're multiplying decimals. You only need to line up those decimals when you're adding and when you're subtracting decimals, all right? So quick multiplication of that, we have 2 times 5 is 10. We group here. 2 times 2 is 4, plus 1 is 5. Now, you notice I am putting my answers aligned with the numbers that are above, sort of in columns, right? That matters. That's really important, but I don't have to have my decimals on top of one another when I write the math problem out. All right, 2 times 0 is 0. Here's my second row, smiley face. 0 times 5 is 0. 0 times 2 is 0. 0 times 0 is 0. I add. Where does my decimal go when I'm multiplying decimals? Remember, we count how many digits there are to the right of the decimal, and there happens to be 2 decimals. So there's 1, 2, 3 different digits to the right of the decimal point. So I start at the end and count 1, 2, 3 spots over, and that's where my decimal point sits. So there's 3 digits to the right of the decimals. So I start here, 1, 2, 3 spots in. So what do I get as my answer? I have 0.05. I can ignore this 0 here, right? Because when there's a 0 after the numbers, that you can eliminate that and don't have to worry about it. So I have 0.05 as my answer. So here I did 1/4 times 1/5 using decimals. Here I did 1/4 times 1/5 using fractions. So these answers should be equivalent. I should find out that 1/20 is equivalent to 0.05. Does it? How could we prove that? How could I prove that 1/20 and 5/100 are the same? There's a couple of, first of all, I'm going to think about it for a minute. I'm not going to spit out the answer quite yet. How do I confirm that this fraction is equivalent to this decimal? All right. So the way that I would do it is I have this decimal, 5/100, and I would think, can I write that 5/100 as a fraction? How do I write a decimal as a fraction? This is review. This is something we talked about before we went on our winter break, right? How do I turn a decimal into a fractional representation? Well, decimals to fractions are really actually very friendly. You read that number. How does that sound? 5/100. What does 5/100 look like as a fraction? It looks like 5/100. Okay? So here is 5/100 as a fraction. Is that equivalent to 1/20? It is, because you can multiply the numerator times 5, and I could multiply the denominator times 5. There's that giant 1 again. 1 times 5 is 5. 20 times 5 is 100. So that confirms that 1/20th and 5/100ths are equivalent. That proves that 1/20th and 5/100ths as a decimal is equivalent. And that proves that these two math problems are equivalent. All right. So what I'm going to do is I'm going to leave this on here for a moment because I want you to write down this problem. I want you to copy down this problem. And right here, this is our proof. I want you to write that down too. All right, great. Now I've got this erased. Let's try another problem. We're going to do this time 3/4 times 3/5. How about that? That'll be fun, won't it? All right, so 3/4 times 3/5. Go ahead and solve that. Remember, you just multiply across the top and multiply across the bottom. And then likewise, 3/4 as a decimal, that's 0.75 times 3/5, that's 0.6. Multiply that out. I said multiply. There we go. Take a moment, solve that up for us. All right, 3 times 3, that's going to give me 9. 4 times 5, that's going to give me 20. 9/20. Not a very friendly fraction, I might say. Okay, let's solve this one up too. All right, 6 times 5, that's going to give me 30. 6 times 7, that's 42, plus 3 is 45. 6 times 0 is 0, plus 4 gives me 4. Smiley face. 0 times 5, 0 times 7, 0 times 0. Add them up. 0, 5, 4, 0. Where does my decimal point go? Again, I have, here's my decimal point, here's my decimal point. I have 2 digits here, 1 digit there. To the right of the decimal point, start at the end, 1, 2, 3. That's where my decimal point is. I get 0.45. I don't have to worry about that 0. It's at the end. Because 450 thousandths is the same thing as 45 hundredths. So having that 0, extra 0 at the end, just kind of makes it a little tricky. So the question is 9/20 from here equivalent to 0.45? How can I prove it? How can I prove it? Well, we know that 9/20 is going to be equal to, what's this as a fraction? 45 over 100, because 45 hundredths. What's the thing I could do to prove that these two fractions are equivalent? What am I going to multiply times the numerator and the denominator? What's my giant one? All right, times 5 times 5. 9 times 5 is 45. 20 times 5 is 100. That confirms that these two multiplication problems, fractions, decimals, are equivalent. So 3/4 times 3/5, there's 3/4, there's 3/5. I'm going to pause this video for a minute. Go ahead and make sure you have this copied down. Okay, great. So now let's do one more problem, but this time you're going to do this on your own as best as you are able, all right? Let's do 2/5 times 1/4. All right, 2/5 times 1/4. What I'm going to ask that you do is figure out, because you already copied the notes from the beginning of this video, what these are going to be as decimals. So you're going to figure out what the decimal problem is. You're going to multiply the decimals. You're going to solve these, and you're going to then prove to me their equivalence. I want you to do all three of those things, right? Solve this, multiply it as decimals, show me what their equivalents are, just like we did in the previous two problems, all right? What I want you to do is take a photo of that, post it in Google Classroom to the assignment that's attached to this video, and reach out to me if you have questions, right? I can always help you out in office hours. That's every A day at 1 o'clock, and I will see you there, right? Let me know if you have any questions. Here's your problem. Solve it up. Thank you.